Sketch the following relationships on the axes provided. We have mod z add 2 is equal to the modulus of z plus 2i. Well, mod z is the distance from 0, 0. Z plus 2i in modulus is the distance from the point 0, negative 2. So we want points so that the distance from 0, negative 2 is equal to the distance from z plus 2. So consider this point here. So consider the point 0, 1. Its distance from 0, 0 is 1. Its distance from 0, negative 2 is 3. So if we substitute into here, we get 1 plus 2 is equal to 3. Clearly, this point is in that locus. What about this point here? The distance from 0, negative 2 is 4. The distance from 0, 0 is 2. Substituting into the equation, 2 plus 2 is equal to 4. So that point is as well. It doesn't take long to figure out that it is all of the points going straight up the imaginary axis from the origin, and includes the origin because the origin itself is at a 0 distance from the origin, at a distance 2 from 0, negative 2, and 0 plus 2 is equal to 2. So the origin is included. So now let's look at mod z plus 5 is equal to mod z plus 4 plus 3i. And I like to write the second one as this. And then we can see that we're talking about the distance from the point negative 4, negative 3. Z, of course, mod z is the distance from 0, 0. Negative 4, negative 3 is just here. And it should be clear that the distance to the origin is 5 units. So if we continue that line on into the first quadrant, it should be clear that any point on here, such as 4, 3, is going to be 5 units further from negative 4, negative 3 than it is from 0, 0, by a similar argument used in the first part of this question. Therefore, the locus we're after here includes the origin, because the distance of the origin from itself is 0, but the distance of negative 4, negative 3 is 5, so that point would work, and so will any other point up here, because that point is always going to be 5 units further from the origin than it is from negative 4, negative 3.